As we have promised that in the last video, as I promised that in the last video that we are going to see more details about the integer type because the previous one is already around 40 minutes, so it's sufficient for one day lecture. So in the third video, what we're going to see now more details about the data types related to the integer. Okay, so let me change the color. Right. Okay. So we'll continue with our integer data types that we are discussing. Okay. So the keyword we are using int. Fine. So let us identify now relationship between the integer and character, because we have seen the character takes 1 byte of memory, and on the other side we can say short integer also same. Short integer can handle, then integer can also handle. So let us find relationship between them. It takes 2 byte of memory. What is the relation and what is the ASCII, right? Okay, so let's go back to the compiler. We have this was the last thing, so now let us create a new project. We have done this, so let's create a new project, so that you can have your programs save into a specific folder and order wise you can have. So let me just check the recording is on. Yeah, recording is on. Fine. Select the language, don't forget to select the language, and I've created a new project and save this. So now we're going to save it in a specific folder, C programming. Okay, and here we're going to store integer. We're going to see versus character relationship. Okay, save. We don't record these comments. We have not discussed yet comment, right? Okay, we'll see the comments. Fine. So let us declare character, right? So that we can understand uh, the relation between character and the integer. So I'll use character and short integer. Do not get confused. Okay, and let us take another one. That okay. I think it is fine. Okay, now use the small case. It should be 2, or give a proper name, upper case A, right? Or in short we can use UCA, and last one we have uppercase Z, and similarly we'll have lowercase a, so lowercase a, and we have lowercase z as well. So let us see the relationship. So let's print them. Okay, all these 4 values. The format specifier for character. What is the format specifier for character? I think we have seen in the last video discussed regarding this. No. Okay, so note down. We'll use the font specifier for character is %C. I think I have discussed this in the last video. Okay, no problem. If I discussed also, we can repeat it many times. Fine. So let us use now same format specifier, a different format specifier for this identifier, for these variables. Okay. Okay. So printf. First one is definitely %C for character, because we are using character here, character specific. And second one, the relationship that we are looking for between the character and the short integer or integer, right? So for the short integer, we are using h, and we'll use signed one. We'll use the positive one. Okay. Now we'll pass them UC a uppercase, and again we'll pass this UC a. Oh, see the things here. Hmm. Now we start about to start that some complexity in that simple topic. Normally student get confused with this thing. We call this topic is called know what this topic is called? Anyone knows? Typecasting. Okay, convert a type to another type, but to understand this typecasting convert a type to another type, we need to remember the byte and bits concept that I just mentioned in the last video regarding that integer. Okay, that is very much necessary. If suppose you are converting, for an example, if I converting type 1 to type 2, anything, it can be int, float, long, whatever. Type compatibility is also there. We need to take care of this. We'll see with the coming lectures or in this lecture, right? If I convert type 1 to type 2, anything it can be. So for an example, if I take character and if I take this one as integer, so there is no need to worry. Why? Because it only take 1 byte, right? And this integer take 4 bytes. So means I can easily uh, 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 keep one no 10 ml water in a 100 ml, not sorry, 40 ml glass easily, no? So that one but can be easily, but opposite one is not possible. So I cannot do the reverse one, not possible. Why? Because it is 4 byte. So a 4 byte information we cannot keep it 1 byte, it will be overflow, we lost the information. So here now let's just go back and execute this and see. See here the beautiful thing in the console. Can I increase the font size of the console? Yeah, I think it is there. Large. Yes. Done. You can see the console that first percentage C. Okay, if you look at the first percentage C, please bear with me. Stay with me, right? It will be lengthy topic. Some boring also sometimes we feel. First percentage C, what happened? Pencil, yeah, first percentage C, uh, get the value from which argument? From the second argument, right? And the percentage HI will take the value from the third argument in the printf. So the values are assigned from, is it right to left? Yeah, right to left. Careful. Okay, just again. Uh, this is the rightmost, so it will go here. This is the leftmost, it will go here. Okay, so here you can see UCA. What is the value of UCA? UCA value is A, so we get it properly here, no issue. But when I use percentage HI, so which is represent short integer, which one? Unsigned, I is signed, I, positive one. Okay, so it instead of it print A, because you are using percentage HI, remember it never can print a character, percentage HI, always print a number. Okay, so it typecast that particular value. Okay, so what is UCA? UCA is actually A, na? So typecast the value in a equivalent integer number. So that is called what? ASCII value. That is called ASCII character. Okay, which is also defined by the organization ANSI standard. Clear? So now let us see more magic here. There are many things remains that I am going to discuss here. So let us identify the range of integer values of lowercase and uppercase. Okay, so I'm just removing it from here to hi again, and now I'm using UCZ, sorry, UCZ, and now I'm pass another percentage HI, so I'm going to pass and another HI. Okay, want to see those values now. So lowercase a and lowercase z. Save this and run. See these values. So please remember these values. We'll record in other lecture as well. So we called it ASCII values. ASCII values. So uppercase A start from 65, uppercase Z ends in 90. So in total, how many values? 26. So we have 26 alphabets, right? So similarly, on the other side, small case a starts on 97 and small case z ends in 122. So again, how many alphabets? 26 alphabets. So similar to this, we'll also have reserve ASCII values for them 0 to 9. Okay. So let me just show you here. 1 minute. So just backslash n, and if I use printf percentage hi again, and again percentage hi, and if I use here now, that is my 0, correct? So I pass as a character, huh? And I have also used have 9. So run it. So see the values, 0 represented by 48 and 9 represented by 57. So others reserved for some special characters we have now, other characters, and some reserved characters are also there. So this is the basic relationship between our characters and short integer, or you can say integer. Even though, let me just show you another one. Suppose I have going to perform some arithmetic operation, right? So even though it is possible, we can we assign a integer character to an integer variable directly? So let us see. So I'm using integer, suppose num, or we can say ASCII ASCII of a equal to and just assign this value. Okay, so these are called, when we use these values directly now, so we call it constants or literals, remember. Okay, so because the meaning of a is always a, so the meaning of a cannot change, the value of a is always a now. What is the value of a? Value of a is a. I'm not representing a as an identifier, I'm talking about this a. So value of a is constant, so we also call them literals, fine. So now let me show you the very interesting part in C programming. Again, it is related to the typecasting between integer and character. Now see here. So I have used integer, right? So format specifier percentage d, right? Okay. So what I'm going to print? I'm going to print its value. So let me just copy the name, and I need to pass it as a second argument to the printf. Fine. So run it. See, I have what I have assigned. So an integer can easily have an character to the right hand side of the assignment operator. So typecasting will be done by the compiler, okay, internally. No need to worry about that, because it can easily adjust the value of 1 byte into 4 byte, right? So opposite one is also possible. So let me show you. Character, you need to use proper data type on the left hand side so that there will be no overflow. Okay, so this, remember, this is called L value and this is called R value. So there should be type similarities are there, so that both the party knows each other. Here we are using character, on the other side we are using float, so then don't know each other properly, so there will be issue, right? So integer and character have some similarity. We'll see another data type also has similarity with the integer, right? Character, now suppose I want to have a character, so char a, and here I have going to assign ASCII a. So I hope you remember ASCII a is an integer, huh? Okay, so now let me print it, so we'll get the idea. Here let us print char a equal to percentage c. So I need to pass it is in the third argument, char a. See, both are reverse also possible. I have assigned an integer, it converted to character, depends on the type of this L value, okay, and here also I have assigned a character but converted to integer, depends on the type that I have specified during the declaration of the identifier. Okay, so in the last video we have, I think last video I remember, I have mentioned about the term constant, right? Constant and variable, two types of identifier. So how we can declare a constant? So C programming have one keyword we have seen in the last, if I remember, history of C programming, the prompt that we have started discussing on C, and the keyword we have some issue with the include. By mistake I called it as a keyword. See the keyword const. Okay. So what is the purpose of this? Explain it. Ask for it. Provide the correct prompt. So we'll get the correct answer. So const is a keyword in C and C++ used for define variable or objects whose values cannot be changed. So that means you can create a constant whose value cannot be changed. This is the syntax. Okay, fine. So let us just have it. So I have declared a constant. X is a constant. Do not forget the semicolon. Right. So I cannot modify that value. So let's try to modify it. Yeah, X. So X equal to 90, and now let's just execute this. So we'll get the error here because X equal to 90 is an read-only variable because I have preceded the type with a const keyword. So const will inform the compiler that it is read-only property, doesn't have write property here. So if you later wants to update the value of this read-only variable, so read-only identifier, we have to identify, not a variable. Okay, although they mentioned read-only variable, yeah, it will be raise an error. Okay, assignment operation is illegal like that. Okay, fine. So remember, done. Character integer, character integer. Okay, so let me see the time. We can go. Yeah, we can further go. So now let us understand the range of values, how they're going to be arranged. Okay. So we'll take a character. Similar rules will be applicable to the other data type as well, because others are very large value. Now we have seen in the previous code. Okay, so I hope you remember. So now we're going to start up a new project. We're going to see the range of values, how we can work. Means how positive values sometimes can print as a negative way. And two things I have not discussed in the last video. We have seen different types of integer in the chat GPT, right? Octal and hexadecimal. Okay, so let me just use one or two example. So the topic is also going to be covered. So in the same here, now suppose I want to declare, and so that line is illegal, so you can comment it like this way. So C programming have two types of comment mechanism. We called it documentation in a source file. Okay, we can comment a single line, or we can also comment multiple lines. So single line will be commented by two front slash, and multiple line and multiple line can be comment. So if I want to comment multiple lines, there it is. Just start the block comment, and you can done. Okay, run it. There will be no output, no error. Fine. So this is the block comment. Multiple lines you can comment. It starts with a front slash. Is it? Yeah. Front slash followed by asterisk, and it is ends with asterisk and followed by a front slash. The reverse order. So now in the same program, we're going to see about the octal and hexadecimal. We talk about in the right. Okay. So how I can assign a value in octal? I hope you know there are four types of number system normally we have in mathematics, right? Okay. So one is the smallest that we have the binary number system. Then we have the decimal number system, then we have octal number system, and last one we have hexadecimal. Okay, I hope my spellings are correct. So binary number system, that is base is 2, decimal base is 10, octal base is 8, and hexadecimal base is 16. I hope you know what is this base. Okay, if you have any doubt, explore with the chat GPT, no need to go anywhere. Means we are using only two numbers to represent all the binary numbers exist in this world. With 1 and 0, any binary number can be represented. Similarly, any decimal number can be represented with the numbers between 0 and 9, both are included. So you can count 0 to 9. There are 10 digits, 10 numbers. So that's why base is 10. And the octal numbers are represented between 0 to 7, and hexadecimal number represented between 0 to 9, and uppercase A to F, or okay, small case A to F. So that's why we have seen in the format specifier for the hexadecimal, there are two types: percentage x, small x, or percentage uppercase x we can use, and for the octal we have a percentage O. We don't have any specific format specifier for the binary, but in the coming lecture we may see how we can convert a decimal to binary through programmatically, right? So let us just see how we can declare them. Okay, fine. So integer, I want to take an octal number. Okay, so integer oct equal to, and I preceded the number with 0, if I'm not wrong, correct. 11 I have assigned. Okay, and now let us printf this, like if I use percentage O as an octal, right, and I want to use octal number here, and let me just execute. So see, I have assigned octal 11. So to assign octal 11, the number should be preceded by 0. So let us take more example. This is octal 1, uh, octal 2. So 0, it's preceded with okay. So and large number I have taken. So any constants that you want to use in octal form in your code, you need to be preceded that value by 0, right? So here again, suppose I want another octal, so percentage O, and I need to pass octal 1 as well as octal 2. Okay, run it and we'll see the both the values are there. But here instead of percentage O, if I use percentage D, you will see the decimal version. See the decimal version. Got it? Yeah, decimal 9 is octal 11, right? So similarly, no need to change. Yeah, similarly we can use hexadecimal as well. So int hex 1, if I just use any combination, any specific format to assign the hexal constants. So let us try one. Let me just compile, see any error or not. Yeah, there is an error. We cannot do this way. I think it should be preceded with 0 and x. Okay. Yes, fine. So any number preceded with 0 and x. So let me just try with uppercase as well. So int hex 2. Now I've used uppercase. So now for we can use characters now. Maximum 6 characters we can use. Okay, 6 characters I have used here, or you can use 4. 4a. And now compile this, no error. So let us print. How to print them? We have already seen. Just recall. We can use this. So these are our hexadecimal values. So we can going to print here hex 1 as well as now hex 2. Okay, so we get the values correctly, and we can replace these values by percentage D in the printf, the format specifier, so it will be converted to the decimal. Okay, so this is the another thing how we can normally do the stuffs with the integer. So now let us go back to the range of values, and after that we'll stop that particular lecture. Okay, so we're going to see with the character, because it is small in range, we can easily handle the stuffs. So now suppose if I take an character, okay, character ch, just naming convention, nothing else. And if I just want to assign a negative value, okay, so the limit is 2 to the power 8, huh? 8 bits, na? 2 to the power 8. So what is the value of 2 to the power 8? 2 to the power 8 value is 256, right? So the maximum values that we can represent is 0 to 255, positive. Now, if I want to do in the negative way, okay, so now as I told, half of the values will be shifted in the positive direction and half of the value will be shifted into the negative direction. Okay, so I am assuming that this is the center point 0, and if 256, if I divide it by 2, it will become 128. So 128 values will be there in the positive direction, and similarly 128 values will be in negative direction. So this is my positive one and this is my negative one. Okay, so now here, now 128 values. So again 128 values means 0 to 127. So how we can represent this? And here minus 128. Okay, so see, no need, sorry, any other color? This one no need. Now if I just want unsigned integer, sorry, unsigned character, so unsigned character, how much it will take? 2 to the power 8. Okay, and what is the range of values? 0 to 255. Okay, now if I come to the signed char, so which sign do you want? I want positive one. So what will be the range now? How I can represent in the form of 2 to the power 8? So what is 2 to the power 7? 2 to the power 7 is 128 minus 1. So this will be the range, no, 0 to 127 for the signed one, positive signed values. Okay, and signed also we have a negative. So there are two part. The negative part, it will be, what is the values? Minus 128. So how to represent it? Minus it like this way? No, 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 no. We can do multiply by minus 1. Yeah, this will be the range. 2 to the power, no, sorry, mistake. Where is the eraser? Where is the eraser, man? So wrong, this is not the negative. 2 to the power 7 is 128, and we can just multiply with minus 1. So this will be the range for negative values. Okay, so we started with 2 to the power 8, and it is divided into two categories. One is 2 to the power 7 multiplied by minus 1, and another is 2 to the power 7 minus 1. Yeah, so similarly for the short integer, what is the category range? 2 to the power 16. So now it will be coming here 2 to the power 15 multiplied by minus 1, and it will be 2 to the power 15 minus 1. So we can check this. Okay, so let us check this, the distribution that I have done, is it correct or wrong? Okay, so this is our negative range and this is our positive range. Similarly, negative range and this is our positive range. We have the min max now, so we can do here just this will be the last part. So we have used, I hope you remember the pow we have used for, no, did you use pow? Not yet. Okay, hash include, will use a library mat.h, which will help us to find the power of 2 to the power stuffs, right? And remember there is a function pow is there, but it will be written with double. We need to take care of this. So printf, so if I want the negative one, so negative one is percentage I, right? It's going to return with double. So format specifier for double in C programming. Okay, or we can also use float, but let us go with the double, the function return the double. So another data type, right? Fractional numbers, 2 by 4, 3 by 4, those number can be represented as a floating point constants. So in floating point there are three types. One is the floating point 4 byte, another is a double, which will be one is what I mentioned. So just for this I explaining, but normally there will be a separate video, don't worry. Float, then we have a double, and the last one will have long double. Okay, so just I'm going to use the function pow, which will take two parameter a comma b, which is nothing but a to the power b. So it will represent the value in the form of double. That's why I just we just doing this. Okay, so let us just ask a format specifier, the chat GPT, percentage lf, if I am not wrong. Yeah, percentage lf we can use, right? So let us try percentage lf, and if I use pow here, and I want 2 to the power 7, right? And minus 1, the value that I want to print. What is the value? 127, right? Okay, so 127 is the signed character positive range maximum value. Signed character maximum value it can have. So let us just check. We have the limits dot h. I hope you remember. So hash include limits dot h. Okay, so let us try with this printf. We have we have unsigned signed character. So our character is percentage c, so we can use do we have UC such kind of thing? uh, okay, I'm using now short signed hi. Okay, percentage hi, and here I am now using that limits.h constants unsigned character max u k max. I hope this is the correct constant I have used. Yes, so it is signed, I think, 255. Yes, now see that signed character max, because it is a negative value. So signed character, the half will be negative, half will be in positive. So what is the signed character max? The maximum value 127. So 127 is what? 2 to the power 7 minus 1, right? So if you want the minimum one, so let me just use another one, percentage each I, and I need to pass CHR minimum. So minus 128. So minus 128 is 2 to the power 7 multiplied by minus 1. So here we can do again LF. Oh, okay, 2 to the power 7. Whatever the value we have, we can multiply it with minus 1. Right? So this is the multiplication operator. Asterisk we'll see after the data type is over. We'll see the operators mathematical expression, how to resolve, how to solve in C programming in detail. So just I want to show you how you can distribute the numbers in signed and unsigned, right? So now here you can see it is the formula that I have written here. Okay. Similarly, you can check with the other data type. So let us just check with the short integer. Printf, what is the formula I have written? 2 to the power 15 minus 1. So short integer, right? And it is signed one. So hi. Yeah, fine. And another also hi. So we can use pow 2 to the power 15, right? And 15 multiplied by minus 1 multiplied by minus 1. So second argument again pow, we need to test it 2 to the power 15 -1. Yeah. Okay, so I provided here to both the arguments, and at the same time we can also check from the library. Hmm? Printf, we need to uh, oh, it is written with double now, so careful. It is lf and it is also lf, so here we can use percentage hi. Yeah, and it should be start with the backslash n. So here also you have percentage hi, right? So now instead what we can do, we can use the limits.h. So I hope you remember shrt minimum and shrt maximum. Yeah, see, our formula is properly fit, right? So this is for the integer data type in detail, relationship between character and integer. Typecasting also we have seen, the ASCII values also we have seen, and how can the negative and positive value is distributed. Okay, total unsigned values can distribute into half in negative, half in positive. So I hope you get the idea. Okay, done. We'll see in the next video with the other data type. Float is there. Okay, string we're not going to introduce now. There is another type of integer. So I think better to finish the integer here. So we have okay, boolean type, actually true false type we'll see separately. Fine. So the next video we're going to work with the floating point types and its signed, unsigned, format specifier, typecasting between integer and float, integer and long double, all those things stuffs we're going to see. Okay, thank you very much. Have a nice day. Fine. Thank you.